Solving two-step equations. In this video, we will cover how to isolate a variable in an equation when two inverse operations are required. In this video, I will do 3 levels of examples, and I'll go over one common error. It would be a good idea for you to write down these examples as I go. In this video, I will use 3 vocabulary terms that are important to understand. The first of these 3 is isolate. Isolate means to get by itself. So our goal when we solve an equation with x would be to isolate x. So we have x equals, for example, x equals 7 would be our answer. Inverse operations are operations that undo each other. So addition is the inverse operation of subtraction because 3 minus 3 equals 0. Those undo each other, so we're no longer adding or subtracting anything. And the inverse of multiplication is division, because if we take a number, for example 2, and multiply it by 3, but then divide by 3, we get our initial number, or 2. A reciprocal is when you flip a fraction, you swap the numerator and the denominator. For example, the reciprocal of 2/3 is 3/2. This is important because when we multiply reciprocals together, we get 1. Some other examples of reciprocal are that the reciprocal of -3, which is the same as -3/1, is -1/3, because we take the numerator and swap it with the denominator, but we keep the same sign. My first example is 2 plus 3x equals 8. To be consistent with last year, I'll draw the line down under the equal sign to remember that whatever I do to the left side, I must also do to the right. In my equation, I'm trying to isolate x. Right now I see that x is being multiplied by 3, and then we're also adding 2 to our 3x. So we need to get rid of our tag-along, or our constant, first, which is this 2. Since we're currently adding positive 2, we're going to subtract 2 to get rid of it, and I need to do it to both sides. So I'm left with 0 plus 3x equals 6, and I don't need to write in the 0 here. Now I have 3 times x equals 6. To undo my multiplication, which is the operation that's happening between my 3 and my x, I will divide both sides by 3. On the left side, I have 1x, or just x, because I had 3 divided by 3, equals 2. I've isolated x, which means that I'm not adding or subtracting or multiplying or dividing anything with my x, and I have that my solution to my equation is x equals 2. Now, of course, over to the side, I want to check my answer. I check my answer by copying my equation, but I write a skeleton equation. So I leave a hole in parentheses where x was, and I can fill that in with whatever value I got, in this case, 2. Now I simplify each side separately. So I have 2 plus 6 on the left, which is 8, and on the right side, I have 8. Since these are in fact equal, I know that I reached the correct solution. You can always check your solutions to equations by substituting in the value, and so there is no excuse for getting them wrong. Example 2, x over 2 minus 6 equals -10. I see that my x is being divided by 2, and then we're subtracting 6 from it. So the first thing I need to do is get rid of this -6 before I can do anything with my x over 2. I'm going to add 6 to both sides of my equation because addition is the inverse operation of subtraction. So I have x over 2 plus 0, and I don't have to write the plus 0. On the right-hand side, I have -10 plus 6, which is -4 because I subtract 10 minus 6, and since the absolute value of -10 is greater, I still have more negatives left. So I keep the sign of my -10, and it stays negative. Now I have x divided by 2 equals -4. Since right now I have division, my inverse operation is multiplication. I'm going to multiply 2 on each side of my equation, and I can put it as 2/1 to help. So I am left with 2 and 2 cancel, so I just have 1x equals -8. A negative times a positive is a negative. Over to the right, I've set up my skeleton equation, substituting in my solution of -8. When I simplify this, I have -4 combined with -6 equals -10. This is true, and therefore I have the correct solution. Example 3, -2/3 x plus 4 equals 12. The first thing I want to do is get rid of my tag-along, or my constant of 4, and subtract it from both sides. We should be getting the hang of that part by now. So I'm left with negative 2/3 x equals 8. This is the part that a lot of times we get stuck on. I'm going to show you a way to do it that makes sense, and then I'll show you a shortcut. So if I have negative 2 times x all divided by 3, which is the same thing as what we have here, one thing I can do is get rid of that 3 right away. So I'm going to multiply both sides by 3. My 3's on the left side cancel, so I'm left with negative 2x equals 24. Since I have negative 2 times x, and multiplication and division are inverse operations, I'm going to divide both sides by negative 2. Therefore, I have x equals negative 12 as my solution. If you want to do this in fewer steps, you might look and see that you have negative 2/3 x equals 8, and how can we get rid of that negative 2/3? Or what can we multiply negative 2/3 by to turn it into a 1? If we multiply by the reciprocal, here's that vocabulary word again, then our 3's cancel out, our 2's cancel out, and our negatives cancel out. If you want to prove it to yourself, do it out. Our numerator is negative 3 times negative 2, which is 6, and our denominator is 2 times 3, which is also 6. 6 over 6 is 1. Now that we've multiplied by negative 3 over 2, we have to remember to do it to the other side. When I multiply these together, I get x equals negative 24 over 2, which is negative 12. Or you can cross cancel and up at the top where I see that there's a common factor between my numerator and my denominator. So 2 goes into 8 4 times, and 2 goes into 2 1 time. Therefore, in my numerator, I have 4 times negative 3, which is negative 12, and my denominator is just 1. Now you've seen 3 different levels of examples. In the first example, we subtracted, and then we had to divide because we had an integer coefficient. In the second example, we added to get rid of our negative, and then we multiplied because our x was being divided by 2. And in the third example, we subtracted to get rid of our addition, and then since we had a fraction of negative 2/3, we multiplied by 3 to cancel out our denominator, and then divided by negative 2 to cancel out our numerator. And we talked about how we could have done this in one step by multiplying by the reciprocal negative 3 over 2 on both sides. But now let's look at one common error. Let's look at the problem 6x equals 2. A lot of you will jump to the conclusion that x equals 3, right? No. We have 6 times x. So in order to undo that, we need to divide both sides by 6. On the left side, we're left with 1x because 6 over 6 is 1, so I'll just write x. On the right side, we have the fraction 2 over 6. We can simplify this because we can divide our numerator and our denominator both by 2 without changing it. This is just like a giant 1. And therefore, we get the fraction 1/3. So our solution is x equals 1/3. We could even check this over to the side. To check 6 times 1/3 equals 2, I'll put my 6 over 1. So I get 6 over 3 equals 2, or 2 equals 2. This is correct, and therefore I have the correct solution of x equals 1/3. Thanks for watching.